So if we returned to our fruit and sales data 2013 and the problem of making the total sales 1,500, which we attempted with the goal seek, but were only able to change a single cell, which meant that we had to sell one whack of a lot of pears in June. In reality, we would want to see a spread of increase across the whole year, across all the fruit range, to meet that 1,500 target. This is where Solver can be a little bit more helpful. So to use Solver, we go to Data, pick on Solver. Now we still have a single objective cell, so we browse to pick that up, and that's our grand total, so G14. Now the first difference between Solver and GoalSeek is that we have a choice of setting a maximum, so we want that value to be the biggest it possibly can, or minimum, so we want it to be the smallest value it possibly can, or to a fixed value. We're actually going to aim for a fixed value, which is 1,500. What we then give it is a number of variable cells, not a single cell that can change, but a number of variable cells. So if I go to Browse, I'm actually going to allow it to change all of our fruit sales. So B2 all the way through to F13. So that's all 12 months and all 5 fruits. Back to Solver. Now at the moment we're going to leave the constraints blank. We're not going to give any constraints to the Solver itself. All it needs to do is make a change to any of those cells to reach our target of 1,500. Now there are 3 solving methods: GRG nonlinear, simplex LP, and evolutionary. Each one of these has further options, but for the moment we'll just leave things as the default, which is GRG nonlinear. You see the option below here. It says select the GRG nonlinear engine for solver problems that are smooth nonlinear. Select the LP simplex engine for linear solver problems, and select the evolutionary engine for solver problems that are non-smooth. So if you know what sort of bracket your solution falls into, then you'll know which method to go for. If you're not sure, then I personally would suggest you stick with GRG nonlinear. So we've told it which cell to change, what our target is, and which cells it can actually physically change to reach that target. Solve. Now it's reached a solution and the target is 1,500, but it has one slight problem in that in order to do that, it's changed all the values, but they're all now multiple decimal places. Well, in sales, we can't sell a bit of a strawberry or a bit of a kiwi or half an apple or 0.63623 of a banana. So that's not really a solution. It works mathematically, but it doesn't work in the real world. So our options now are OK. Let's keep the option. Cancel, which will take us back to where we were. Or we could put restore original values and OK, and that will take us back to where we were. Or we could save these values as a scenario. So effectively saving this set of numbers away in the scenario manager for us to then go and use another set of numbers. Well, for the moment, we're going to go with restore the original values and OK. And we go back to where we were. So the problem was, if we go back into Solver, they wanted to change the values into non-decimals. So we need to add a constraint. So we're looking at this section now. So the constraint that I would like to add is that all of the cells, that's every cell from B2 to F13, must be an integer. So there's our option, int, and then that changes the constraint to integer. So all of these cells must be an integer. OK. And that's enough of a constraint for the moment. And then we try solve again. And this time it takes a little bit longer. You can see down the bottom left how it's thinking. It's going through various subproblems and different trial solutions. And then it gets there. This time, if I move that over, we can see it's still reached the target of 1,500 and it's kept everything as an integer. So it says here, Solver found an integer solution within tolerance. All constraints are satisfied. It is possible that a better integer solution exists. To make sure Solver finds the very best solution, set the integer tolerance in the options dialog to 0%. So giving it no flexibility at all, but it did manage to find a solution that were all integers, so I'm happy with that. Now we could keep the Solver solution, but then I lose my original values. So what we'll do is we'll save this as a scenario. Scenario name, Solver 1500. OK. Then we hit that other problem, and the scenario can have no more than 32 variable cells. And I've got 5 times 12 is 60. I can't have a scenario in this case. So cancel, we'll go back to here, and let's restore our original values, because it wouldn't take 2 seconds to rerun Solver. And what I'm going to do is I'm going to copy the sheet. Call this data original, and call this data resolved. And then again, just run the solver. Now notice that when you go back in, It remembers all the variables anyway. It remembers which cell I'm changing, to what value, which of the variable cells I'm allowing it to change, and then any constraints that I might have added. Solve, and it comes up with its solution, still reaching 1500. So I want to keep the solver solution. OK. So that's how to apply a solver solution. Much, much better tool than the goal seek, because we're allowed to make changes to multiple cells to reach your valid solution.